Assalamu alaikum. I'm Mohammad Sarmad and we're going to talk about advancements in fault tolerant systems. Fault tolerant systems are crucial for ensuring the reliability and resilience of parallel and distributed applications. In this presentation, we will explore key advancements in fault tolerance, highlighting their impact on real world systems. Now let's look at what is fault tolerance. Definition. It's the ability of a system to continue operating correctly despite failures in its components. What are the key goals of fault tolerance? The key goals are minimizing downtime, ensuring data consistency and integrity, and maintain service availability. Now, why is fault tolerance important in parallel and distributed systems? Due to the high complexity of these systems, interconnected nodes increase the likelihood of failures, and that's why we need fault tolerance. Data sensitivity. Distributed systems often handle critical data, requiring stringent reliability. Real world applications. For example, banking, cloud platforms, autonomous vehicles, mission critical systems like aerospace and healthcare. Now, these are really important fields and we need fault tolerance. Key advancements. Now, there are a few techniques in fault tolerant systems. Let's look at a few of them here. Replication technique, redundancy. Redundancy is a critical component in modern fault tolerant systems. This involves maintaining multiple synchronized copies of critical data and system components so that if one node or one cluster of data fails, we can still get the desired output from another cluster of data. Self healing architectures, systems that automatically detect and recover from failures. For example, most IDEs. While we're developing code, we see that in real time, the IDE can tell if we have an error in a specific line of our code, so that we don't have to rerun the entire code at the end when we run the code. Instead, it tells us in real time. Another technique is checkpointing. Checkpointing is a critical technique in fault tolerant systems, allowing applications to recover from failures by periodically saving the state of computation. This allows the application to restart from the last known good state rather than having to start over completely. Tools and frameworks. Now, there are a few tools in fault tolerant distributed frameworks are Apache Kafka, Hadoop HDFS, and Google Spanner. The tools we use are Prometheus and Jaeger. Let's look at a few case studies. Google File System, GFS, it's a built-in redundancy and fault tolerance. It powers Google search engine and storage infrastructure. AWS Cloud Service, fault tolerant architecture with multiple availability zones. Netflix Chaos Monkey, it's a tool for testing resilience by randomly terminating instances. Future directions. Now let's look at where fault tolerance is headed towards in the future. Adaptive systems, it can be used in AI powered systems capable of dynamic reconfiguration. Decentralized fault tolerance, it can be used in the expansion of blockchain and peer to peer protocols, as we know that the world is going towards cryptocurrency and that can be very useful in this field. Bio-inspired fault tolerance, we can mimic biological systems for better resilience so that doctors don't have to perform on real humans, instead they can do it digitally first. Post-quantum fault tolerance, it's preparing the distributed systems for quantum disruptions. It's another field that we have developed quantum computation, but we don't know yet how are we going to use it. Conclusion. Now that's a wrap on this presentation. Fault tolerance remains essential as systems scale. Continuous innovation enhances reliability and efficiency. We need to embrace new tools and paradigms and build systems that are resilient by design. Thank you.